ভাই স্ক্রিন শেয়ারের পারমিশনটা দেন।
শেয়ার করতে পারতেছো?
হ্যাঁ,
ওকে।
আমার স্ক্রিন দেখা যায়? আমার
ইয়েস।
স্ক্রিন কি দেখা যায়?
ইয়েস।
হ্যাঁ, দেখা যায়।
ওকে, so everyone online.
Yeah, we join. We join.
Okay, I think, yeah, let's wait few minutes. Usually this takes only 40 seconds, but in Friday, uh, we don't know why it takes 120 days, 120 second almost.
No, that's okay. No problem.
Yeah, yeah, it should be ready. Yeah, it is ready. So you see this, this is now in ready state. That means you can read from replicas and write from primary. Let me. Oh, sorry. Yeah, you see the role. So zero is the primary. Okay, suppose
Primary.
it's
Okay.
zero is the
Okay.
primary, and the other two is standby. So let me
Okay.
try to write some data in it. Okay. So let me just verify, yeah, whether this is primary or not. Uh, okay. Yeah, you see, this is not in recovery. That means it is a primary. So let me quickly show you the replication. So let me create a table. Get table. Yeah. So quickly try to see it from other Postgres. Yeah. So, so you see the data table is here. I'll just quickly insert some data.
Okay. See, below one, below right hand one, which one is that? Is it a reader or what
This
is
is
that?
a read only replica. If I run
No,
the
okay.
same
Okay.
query, uh, you see this is saying true. That means this is a read replica. Uh, we will just insert some data and we'll verify. You see, we have inserted this amount of data. I'm just going to query. You see, so the replication is working, right?
Right. Okay.
Yeah. Let me just open another terminal. Yeah. So now I will perform a failover. Okay.
Mhm.
So this one is the primary, right? So
So, whatever we are doing is only in single cluster.
yeah, in a single cluster. For now, we're doing a
Okay.
single cluster. Later, I will show you in a multiple cluster.
No, no problem. No worries. Go ahead.
Yeah, yeah, yeah. So we have terminated this port, and now you should see other port should be a primary. Any of them.
How much time it will take to fail over? How many?
You see, it's already primary now. So maybe 5 or 6 seconds it take. So this is the suppose gets on, and let me try to see that whether this is really a primary. You see that only take 5 or 6 seconds, right?
Hmm.
Yeah. So select is in recovery. It will show false. You see that this is only false. And now if I try to insert some data in it, you should see it will immediately synced up in the other standby. Yeah, it will take some time. Did I insert it? Yeah, okay, the state is critical, I think. Okay, the state is ready again. So let me just try to exit into the other pod also. Uh, 0, I think. Okay. Yeah, I think this one is updated. Oh, okay. I got it. I had to reconnect again to see the data. Yeah. Yeah. Okay. So see, this one is now standby, right? So this has the done the failback,
Right. Yeah,
right?
go ahead.
And this is the
I
primary.
understand.
Yeah. So this is the feature that you wanted to see, right? And now I think we can try to show the remove from multiple cluster. Okay. Is that okay for you?
Right. Yeah, continue.
Yeah. Okay. Yeah. So let me just show you that this is different cluster. Uh, you see, I have exported this particular kube config, and I will just show you kube slice. So this one is this particular machine, okay?
Okay.
32. And let me show you this one. Um, kube slice worker one, okay? So this one is this on 40 machine, okay?
Okay. Right.
Yeah. And this one is similarly this one from 92. I can still show you. Sorry.
One doubt, huh?
Sorry.
One doubt. See, you're using cube slice in your demo cluster, but are you going to deploy this even in production? I mean, cube slice will be the decision maker there?
No,
Or,
sorry. No, I have just named it cube slice orca, the cluster name.
what is the use of cube slice here?
Uh, I think this was the first POC stage that we. This is the same cluster that we were, doing the POC at our first earliest stage, maybe 3 or 4 months earlier. Then we named it like this, but this
Okay, so
basically nothing to do it. Yeah.
okay, so you are not using any cube slice
No, yeah,
CLI.
we're using.
Uh,
Yeah, we are using QSlice because QSlice is basically needed for networking, right? Because you are
correct,
in different cluster. Your
correct.
networking has to be managed using a VPN. So basically, we are using QSlice for that.
No,
That
no,
is,
the question was different. I understand
yeah,
why you are using cube slice,
yeah.
but will it not conflict with Azure or AWS network, or in case if we want to go with
No,
Cilium
no,
or something, will it not
I
conflict, Calico or something?
no. I think this is CNI agnostic because they use some overlay networking. As far as I know, you can still use your CNI in your cluster, and your internal communication inside a particular cluster will still be done using CNI. I mean the CNI that you are using. But the when you are going to do the inter-cluster communication, that means from AWS to GCP, then you cannot do it using CNI, right? Then only you are using kubeslice.
Correct. Okay. Oh, so you are using at the okay.
Yeah,
At the top of cluster you plan to use the cube slice. That is the
right,
architecture.
right.
Right. Okay. Got it. Go ahead, please.
Yeah, okay. So give me a second. So and we will have to apply the Postgres in a master cluster. By master cluster, what do we mean? We mean that we have KubeDB installed in this cluster. Oh, sorry. You see that we have KubeDB installed in this cluster, but if we try to get those in other cluster, I think we will not find any such spot. You see, none, no pod of KubeDB in this namespace. So this is basically your general cluster. You don't have KubeDB related anything in this cluster, or neither
Right.
in the worker 2. Yeah. So now I will just apply the same YAML. The only difference between the previous YAML and this YAML is this particular field. You see, for this one we have distributed set to true. Generally, basically this is the change that you need. No other changes. Okay.
Mhm.
So I'll just apply this one.
And the reference is for placement policy.
Yeah, okay, sure, thanks. So I think we have another resource that I also need to show you, which we call placement policy. So basically, what is this? This is basically, let me just show you the YAML. You see, so this is basically a template where we are saying that we want our replica number 0 to be present in the cube slice master, our replica number 1 to be present in the cube slash worker 1. I mean the cluster that we created, right? Then the cluster has same name. Okay. And we want number replica 2 to be in the class cube slash worker 2, right? So this is the thing that we will give you, you will give, and few other thing also. Project name, demo slice. We have, what are these? We have documented them in our docs. Okay. So we can show you the link later, this demo. So is that part clear? Basically, this is
I
the,
got it.
yeah.
You are
Okay.
referring about the placement groups of the parts.
Right.
Right.
Okay.
Go ahead.
So yeah, let's just apply this on. So as I said, the internet is little bit slow for Friday. So I think this will take quite some time, maybe 5 or 6 minutes. Yeah. As we are, doing intercluster, and we use some other components that has some latency for updating, uh, you know, updating the status. Like we have a pod or anything that will be running inside this cluster, right? So our master cluster do not know whether this pod is still running or not, right? So that
One second.
status that
One
status needs
second.
to be, yeah,
One second. I have one basic question here.
yeah,
See, when we are running in single cluster,
yeah,
all three parts were part of that same cluster, correct?
yeah,
It can
right,
be one master and two replicas were part of the same cluster.
right,
But when we are running in multi-cluster,
right,
writer is running in one cluster and other two readers are running in different clusters. Is
right,
that
right,
it?
right.
Oh, okay. So we are not going to have three parts in same cluster, correct?
Right.
Okay.
Yeah. So you will see for now this AC Postgres 0 is created in the master cluster, right? As we said in the placement policy.
But
And
don't
we
you
should,
think that will be a problem?
why is that? I
I
mean,
mean,
that is the main distributed policy, right? I mean, how else you can achieve distributed system? We have another concept named remote replica. I mean, I think
correct.
I think I understand what you have said. Let me just show you that.
Problem with this is like in case split brain is the biggest problem across the clusters. And the second thing,
Hmm.
if we are running any read loads like report generation or something on the primary cluster,
Hmm.
that will not work because we need to use only writer mode there. We cannot have any reader, right? So reporting and all will be a problem. For reporting, either we record or we don't record, we need to go to cluster 2.
Sorry. So the last question I didn't understand.
I mean, if you are running reader in different cluster
Hmm.
for reporting,
Hmm.
in case if I'm running my
No,
reporting
this will
in
work. This will work. Let me show you. Okay, Seagate, I think service, right? Mm. Service export, I think Seagate service export. You see that we have services, right? I suppose guess this one. This is the primary service, and this is in the standby. I mean the master cluster. Regardless wherever your primary instance is, regardless wherever whichever cluster your primary is, okay, this will be your entry point to the primary. Okay, and this will be your entry point to the standby, regardless wherever cluster your primary is standby is. You got that part?
I got it, but it will be single pod, right? Don't you think it will be a problem? Because load and all will be a big issue, right?
No, you can distribute the load using PC bouncer or PC pool if you want. I mean, PC pool can distribute the read and write traffic, right?
Oh, okay. So, okay. So
Yeah,
you have a PG pool inside your controller already?
yeah. I mean, we also have PC pool.
Okay.
Yeah,
Okay, fine. Maybe distributed is one thing.
yeah,
Probably even I would like to see that replica, remote replica.
yeah. So let me just quickly tell you what is this. I mean, like you have a Postgres running in a single cluster, and then in another cluster you can have a replica of that particular
Right.
cluster.
Yeah,
And
go
this is
ahead.
only
Go ahead.
read only, right?
Right, go ahead.
Okay, so you see the Postgres is now in ready state, and if I show you in the master cluster we have SA Postgres 0. In the worker number on, we have SA Postgres on, which is a standby, as you can see, and in worker cluster 2 we have a standby also. And the fun thing is, these all three pod are managed by a single stateful set application, right? I mean, in general, what happened is, whenever you deploy a stateful set, then it can only be managed inside a single cluster, right? It cannot manage pod from other cluster.
Correct.
Correct. So we have engineered this thing so that it can now manage pods across different clusters. So these are the
Yeah.
same, you know, pod from this particular
No,
stateful
no,
set.
I understood why you are using cube slice now. I think it is pretty clear now.
Yeah.
Go ahead, please.
Yeah, you see that this is, so this is basically the mother of these resources.
Right.
Okay. Okay, so now let me show you the replication for now. So 0 is the primary, right? Yeah, 0 is the primary. Okay, so okay. Okay. Yeah, so we have done the. Let me try to see it from here. Okay. Yeah, you see that the replication
Yeah.
is
Okay.
working.
Good.
Yeah. So now I think I can try to show you the failover. So as the network, one thing for failover, we basically depend on Raft, as I have told you earlier. So if there is a network related issue which we have currently in Friday in Bangladesh, it might take some time, but I think eventually it will work. So I suppose because 0 is the primary, right? So I am going to turn it down, and some other port from some other cluster should be a primary. Standby, standby. It will take some time, I think. Yeah,
Let's see.
standby. Let me check the log. Yeah, you see that this one is the primary worker number 1. You see? So let me just try to exit, select PZ. Let's see, recovery. Yeah, it's now primary, right? So let me try to insert some data here also. Query the copy the query. Yeah, so it has inserted, and now let me wait until this comes and see if it is joining as standby. In the meantime, I think I can check it here. Yeah, so it propagated here. Now let's wait for the port to come up.
Can you go to
The-
reader?
Yeah, this is the reader.
Can you write something here? Create a record here.
No, the write will not happen. Okay, so let me just still write this. Yeah, you cannot. This is basically read only transform, right?
Good. Okay.
Okay, so now this pod is running now. Let me try to see if the process started. Yeah, it is trying to start. It will take some time. Okay, so yeah, yes, okay now. So let me show you. Yeah, you see that the fallback has happened perfectly. So now if I try to insert again, we should see the data has been replicated here. Yeah, you see that? Now it is 333. Yeah. Yeah. Okay. So is there anything that you want to see? And the database state will be ready soon. Yeah. And critical means basically you have your write going on perfectly, but the replica is not ready. Okay. So now ready means you have both your write connections and read connections also.
No worries. I understood. Can you show me one read replica? I mean, remote replica.
Uh, you want to see the demo?
Yeah, I mean, you need to set it up or.
No. Yeah, definitely we need to set it up and we need time for that. Yeah, I think.
I got it.
Yeah.
That's
So
okay.
basically, I can give you the overview. I mean, how this thing will work, and so that you can understand, and you can also try it by yourself. This is very, I think,
Saurabh,
straightforward.
I would suggest you can give the overview, and let's say
Yeah.
after trying, if they feels like we still need to demo, we can do that anytime.
Yeah. Sure.
No worries. You can show me the
Yeah.
architecture. That's okay. Show me the
Yeah.
architecture.
Sure. So basically, the architecture will be like in a primary cluster. Let me go back to this one. Okay. So this is the cluster where we have everything in a single cluster. Okay. Right.
Go ahead. Yeah.
Yeah. And then the remote replica will be in some other cluster, and it will be pointing to the primary of of your previous cluster. Okay, and it will kind of basically do the replication part, so that
Okay.
whenever we insert something in the primary, the replica in other cluster will also get the data.
Correct.
Yeah. So in a situation where your primary cluster goes down, you can promote your remote replica cluster, so that it will be available to do the read and write.
Okay. So the promotion is a manual step, is it?
Yeah, this is the manual definitely, because we do not know when your cluster goes down, right? I mean your primary cluster. But for this one, this is totally automatic. I mean this setup. I mean distributed setup, because you see that we have deleted the pod in this cluster, and it was already in some other cluster. There was a primary available for read and write
No, no
queries.
problem. No problem.
Yeah,
I think I understood what you mean.
yeah,
I got it. Can we go to Druid?
yeah. Sure. I think Rabbi can show that. Yeah.
Yeah. Are you any questions?
Okay.
Yeah.